Crypto AI agents are a phenomenon that has exploded in popularity in the last 2 months, and it's mainly due to the success of AIXBT and Goatse, two projects that have a combined market cap of over $1 billion. And now hundreds of agents are being launched every day on Twitter and Telegram, all thanks to Eliza OS. Eliza OS is a framework for building AI agents, but if you want to build something non-trivial with it, it's actually kind of difficult to navigate because there's very little documentation and you're not sure where to put custom logic. Now, just for a little bit of context, AIXBT is an AI bot that responds to user queries of token analysis. So users would ask them, hey, what do you think of such and such token? And it would respond back with, some thorough analysis with some insights about this requested token. So in this video, I'm going to actually show you how to combine actions and services in Eliza to create like a clone of AIXBT. Now, in order to make a clone of AIXBT with Eliza, what we're going to need to do is define a service that's going to be responsible for fetching data from outside the application. This could be API calls, calls for off-chain data, on-chain data, things like that. And we'll just encapsulate it in this service. The way this should work is that we would receive messages from the user, and then we would have to parse the message to see if it's actually asking for a token analysis. And if it is, we would pull out the token symbol and pass it to our newly created service, which should fetch all the necessary data that we need. And the final part would be us taking this data that the service provides and injecting it into an LLM prompt, which would then render the final response to the user based on our AI's character and other tools that we give it. So in the video, I'll actually just show you the final code and where all the little pieces go. And you can play with it yourself by cloning the forked repository with the link in the description. So what you want to do first is just clone the repository. It's right here under GitHub. I've already done this. Once you do that, you'll have to do pm install. And as a second step, in another window, you want to do pm start client. Now, this start client gives us a front end so that we can test out our agent. We can send them messages and it'll respond within this client. That's what pm start client does. So the very first thing we want to do is we're going to open up a file in the packages core source types.ts and navigate down to where you find this enum service type. And we need to add a token analysis service. This is very important we do this first because we have to rebuild all the packages in order to use this. Next, we're going to set up our character, our AI character. And for that, open up eternal AI character.json file. This is found in the characters folder. And the only thing we're going to do here is change the clients and add direct. And we're going to use the model Anthropic because we want to use Claude for this just because it's my favorite at the moment. Now that we defined the service type in the enum, we have to pm build so that we actually have access to it when we import it into the agent code. Now here comes the fun part. We're going to define a service in the services folder. I just created a new one here under source, agent source / services, and I just called it token analysis. And what we're going to do is we're going to extend the service provided by Eliza OS. So you can import that. I just have some placeholders here. But what this is going to do is this is going to sort of serve as the interface of the external data fetch. So this will encapsulate all the fetching of this valuable data that we need for our token. So let's quickly go through the service. It's just going to return some valuable data given a token symbol. In this case, I chose some arbitrary metrics, number of current holders, things like that, price action. And as well, I've defined a string method that's actually going to return what this data means in natural language. This is for later use that we're going to pass to the LLM. You'll also notice that we have service type.token analysis available for import from the core package. Now, we have our service defined, but how does the actual program know when to use it and where do you use it? In what part of the flow? That's where actions come in. And actions are basically the tools that we offer the LLM when a message comes in. It all becomes part of the final prompt or one of the final prompts. So within Eliza, actions are the tools that you can define to actually pass to the LLM. And now they have a structure, but in the end, once the final prompt is constructed from this message that we get from the user, Eliza will stringify all the actions that are relevant and present it to the LLM saying, hey, based on this message from the user, what tool, if any, would you use here? So what actually happens is that when a message comes in from a client, and a client can be Twitter or Telegram or a chatbot like we're using now, it actually goes through a pipeline where within this pipeline, a prompt gets generated to be passed to the LLM. So depending on what actions we have defined, those actions could get included inside the final prompt. So this is why an action has a validate and a handler. A validate tells the pipeline whether they should actually include this action based on the message. So let's take a look at our validate function here. What we have is a context, which is the prompt that we want to send to the LLM, and the actual call here. Now, what's the prompt? So this is how we extract whether the message is related to our token analysis or not. And the prompt is actually here. So we'll take in the user's message, and we just have a prompt that asks the LLM to figure out whether this message is asking for a token analysis. We then just pass it to a generate true or false. This is a helper function by Eliza, and it makes the LLM call given this context, which is the prompt, basically. And that's what we return. So the validate function is actually very important in our use case because we're trying to clone AIXBT. And AIXBT will only respond to certain users, and that's because the criteria is that you have to be holding their token and et cetera, et cetera. So in this validate function is where you would put any sort of custom validation. If you want a token gate, if you want a payment gate, this is where you would do it. And that's what makes this part so powerful. Now that we have the validate function complete, what would happen is that when a message comes in and it is a message asking for a token analysis, once we compose the context within our client code, which I'll show you in a second, this action will be included in the final context to the LLM. So it would be something like, based on this user's message, which would be a token analysis request, and these actions available, what should you do? And then the LLM would probably respond, analyze token action. We would get that response within our client code and then call the handler function. Now, before we get to the handler function and when it's called, let's take a quick look at the actual client code. And in this case, we're using the direct client, which is just the web interface where we can chat with our agent. And this is where all of these functions get called. So for example, it really starts down here. It will add the message from the user here to memory, and then it would compose state. Now within compose state is actually where it's pulling all the character file data into its own memory. And then in the next step here, we are composing context. Now this is where our validate function or our action actually gets included or doesn't get included in the final context here that we're going to pass. And that's because compose context will take all the actions defined for the agent and run the validate function to determine whether this action should be included in the context or not. Now that we have that, the generate message response actually makes the LLM call, and the LLM here would basically choose one of the actions available to it from the prompt. We then use that response to call the process actions on the runtime, and this is where the handler function for these actions defined runs. So all the actions that have been validated, they get their handler function run here, and this is the callback that is passed to the handler function signature. So we can take a look at that next, but this is how you capture the value that's coming back from the handler function. The cool thing about this is that this is completely customizable. You can introduce other services before any sort of validation happens. You can chain together multiple actions. It's really up to you and what you put in your client code. We're just going with the given example of the existing code in the direct client here. And so now let's just jump back into the analyze token action and see how we handle the actual handler function. And so what's happening here? We have this token ticker template. where we pass the message content. And what we're really doing here is we're creating a prompt that we're going to use to extract a token symbol from the message, because we need that to pass to our service that's going to actually fetch this, insight data, this valuable data that our service provides. And what that looks like is something like this. I mean, it's just asking for a JSON of, a token symbol here. And if you come back down, then we are using a helper function that also calls an LLM, but it returns us an object, an actual JavaScript object. So it does a little bit of the housekeeping and makes things much easier to extract. And this is where we actually see it here. So now that we have the token symbol, we can actually pass it to the service. And the service is on the runtime. The reason it's on the runtime is because we have to pass it into the runtime initialization of the agent, which is here in agent/source/index.ts. We pass both our action and our service so that we can then access it off the runtime. And that part is right here. As you can see, get service, we pass our service name, and now we have in our IntelliSense the generate insight data function available off the service. So you might be wondering, even when we get the data, how do we actually get a message back to the user that sounds like a bot? And this is where we do a compose context again. And this time we're going to call an LLM with this JSON data, but we're also going to give it the actual schema of what that data means, which is what I showed you earlier here, this string. This is the shape of the data we're returning, and this is what you need to know about it. That's kind of what we're telling the LLM. And so we just create a new prompt using compose context. We pass in the data that it needs. And we also have this template to use for that. And I just have basically a simple one here, but all these placeholders are extracted from the state object, which is passed into that compose context function. And so I've added also for example, our insight data scheme placeholder here, which is going to be part of the object that we passed, as you can see here, insight data scheme. And so this is the special sauce, because we are actually taking this data that we've fetched from external sources and we're plugging it into a special prompt that we're passing to the LLM saying, hey, this is the data of a token, blah, 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 generate an insights take or tweet or whatever to respond back to the user. And that's exactly what happens here. Compose context creates this prompt, generate text makes the call, and then with the callback is where we're returning this to the client or whatever has called the process actions on the runtime. So now let's see this thing in action. We are going to start our little character agent. That should come up in a second. We have our direct client running here. Now let's see, it's there. Let's see a little chat. And what's your take on chaos token? Let's see what we get. We can also see it working here. Normalized action, analyze token. So we have chaos living up to its name with explosive growth, 1 million holders, price surging 20%. And yeah, that checks out, because if we go back to our cursor and our service, you can see that I just returned some fake data here with a 20% change. So it is working. It's working basically how we intended. It's figured out that this is what all this data means. And now let's also check if it's going to do this if we ask it something else that's non-token related. So how about we go, how are you today? So great, the validator did not return true for this kind of message. And that's pretty much it. Hopefully this is a good starting point for you if you are getting into Eliza, or you are interested in creating something a little bit more advanced, kind of like AIXBT. If you have any questions, feel free to leave them in the comments. You can browse the repository. It's going to be linked in the description.